Okay, so we're going to talk about the scientific method and, of course, the Daubert trilogy here this weekend. And it has been extremely important and increasingly important area of law. I was thrilled when I saw the Daubert decision in 1993. Really struck me as an honest attempt by the court to kind of get things right and push the world down a pathway that is, I think will help get things right over time. But here it is, let's see, 10, 20 some years later, and we're still wondering exactly how Daubert applies in different situations. Now, what are the Daubert factors? You just remember, you heard it here first. Well, you've heard it a lot of times, but today, this is the first time you'll hear it. You'll hear it many times throughout the course of the day and the seminar. So Daubert allows a trial judge to admit expert testimony that is relevant and reliable. Relevant, does it assist the trier of fact in determining a fact at issue, whether that fact is more likely than not, and reliable, and that's where we're going to kind of focus. And so the trial judge can do this if the body of knowledge or the underlying theory on which the expert is basing his testimony or her testimony is generally accepted as reliable in the relevant scientific community, is subject to and has been subject to peer review and publication, it has a known or knowable rate of error, and of course implicitly in that is the issue of whether you can reproduce the results. And finally, and what I want to talk about today, whether the theory or body of knowledge is testable or falsifiable. All right? And of course, has it been tested and has it withstood attempts to falsify it? And that's what we want to just call a scientific method. Otherwise, the judge should, according to Daubert, exclude the testimony. So this is actually the world we're in. All right? I've actually been an expert's expert. It was an interesting little case. An aspiring and up-and-coming pianist was injured, and she was just in her career when she was just kind of ready to launch. And she was injured in a car accident. And then the claim was she'd lost income because she's no longer able to play the violin. Was it violin or piano? I'll say violin. The way she had before. And the plaintiff's expert was ready to testify that she had gone out and discovered basically the data and information necessary to kind of project the lost income stream of the violinist. And so what she did was she went to an agent, a talent agent in the business, talent agent who had represented any number of top performers in that kind of niche. And that talent agent said, well, I've got this performer, I'm an agent for this performer, and this performer, and this performer, and this performer, and the plaintiff, I think, is just as good as these people. And here's what they earn per year. And so what do y'all think of that? Okay. My first question was, well, did he represent her as well? Did he offer to represent her? No. In fact, she sought representation and he had declined to represent her. All right. Anyway, so in that case, what we want to do in that kind of situation is come up with comparables, right? Because we've got this thing in economics called the law of one price. That two assets in the marketplace, in this case the asset is the talent, can generate an income stream into the future. We want to compare two otherwise identical assets, and if we can come up with that comparable, we have a prospect of actually projecting that income stream. But anyway, so they withdrew the offer of testimony by the expert in that case. All right, well, let's start with some three questions. What is science? We're going to talk about. It's kind of an abstract and general question. But then more importantly, what is the scientific method? And then we'll talk about whether economics is science or does it follow the scientific method. Now, one of the hallmarks of science is the ability to imagine a theory that's testable and to predict phenomena not yet observed. Right? Now, does that necessarily mean the future? Phenomena not yet observed? How many people as a young lawyer or whatever, pre-judging, have conducted discovery? Okay? What you're looking for something that has yet to be discovered, right? It's there. It just hasn't been discovered yet. Okay? So in that case, you might say, well, you know, these three oligopolists, I believe they're colluding, and we're going to sue them for a violation of Section 1 of the Sherman Act. And based on the behavior I've observed, what I expect to find in these files is something that we haven't yet observed. And of course, you got to make your case, and increasingly that discovery space is getting narrowed with predictive search and so on and so forth, right? All right. In any event, so you might say, economics, a science? Are you kidding me, Johnsen? And I'm going to tell you, economics is an extremely powerful science, right? More powerful than physics. Believe it? Economics is more powerful than physics. All right? Let's do a little experiment. I'm going to take a $20 bill. Just set it right here. Don't rush up here at once. So I'll just put it on the table. Newtonian laws of motion, what does it predict? The $20 bill will remain at rest. I know we got a cue for chat, but if people want to blurt out, I don't care. That's fine. Just keep your mask on, I guess. So Newtonian physics predicts the $20 bill will remain at rest. What is economics? We go away, come back tomorrow morning. What does economics predict? The $20 bill will disappear. Economics is extremely powerful. What's that? I didn't hear you, Mike. Oh, no. Newtonian physics, there's a caveat, right? The $20 bill will remain at rest unless it's acted upon by an outside force. That's, Johnsen, you're trying to trick us. All right, so let's just make the experiment more interesting. I got a piece of paper exactly the same size as a $20 bill. I'm going to write $20 on it. Put it there. Come back tomorrow. I predict, if we did this a bunch of times, that in a much larger proportion of cases, that $20 bill is going to disappear, and that piece of paper is going to stay right where it is, depending on how proficient the cleaning crew is, right? Okay? So, I mean, you know, this is kind of funny and, you know, maybe helpful, but it actually provides some insights, right? In the sense that physicists explain different things. They're working on explaining different stuff than economists are working on explaining. Right? I might even say economists have a much tougher job, right? Because, you know, electrons don't cheat on their taxes. People cheat on their taxes, or they hide their income, or they, you know, they're maximizing. They're out there trying to get more, whereas, you know, electrons, they don't really care. As far as we know, you never know where we're going to end up on that one. Okay? So predictive power is the hallmark of a science. And again, it doesn't have to be predict something in the future. And it's also true that, people say, well, economists can't do controlled experiments. Well, first of all, in the natural sciences, there's a lot of stuff that isn't a controlled experiment, that they can't control, right? Planetary motion. They might, Edmund Halley predicted the appearance of what we now call Halley's Comet years in advance, based on his kind of theories of planetary motion. He couldn't do an experiment. He just had to wait for the world to unfold. And by the way, economists do plenty of experiments now. Henry and I had a colleague at George Mason, Vernon Smith, who was kind of won a Nobel Prize and one of the leaders or pioneers in conducting laboratory experiments. I think they started with mice, but eventually they got to undergraduate students. I'm not sure if that was a step up or down. Sorry. No undergrads here to defend themselves, so I'll withdraw the comment. All right, finally a fourth question that I got grayed out. I don't know if we're going to have time to actually address this, but one question you can ask is, okay, you got this, this scientific method and predictive power and so on and so forth. And the question is that really how it works? And there are a lot of people who will say, no, that's not really how it works. They might call themselves sociologists of science or something, or sociologists of scientific knowledge. I hope we have a chance to talk about that for a minute. But my view is that, there's a lot of things going on. Again, people don't pay their taxes or they cheat on their taxes. Scientists are not people who are unbiased or who we can rely on to be unbiased. Right? They want their research grants renewed. They want to get their papers in a good journal. They don't want some kind of agenda they've been working on, intellectual agenda, legitimate, for the past 20 years to suddenly be tossed out the window because there are contrary results. So people, including scientists, are self-interested. All right, so what's science? I see science, when we use that term, we're kind of thinking of a collected body of knowledge. And let's hope, and then the experience has shown that it's an advancing body of knowledge, kind of constantly moving forward. Maybe the goalposts to which it's moving are being shifted, that's quite possible, but it's a lot like the common law. You can think of the common law either, as a body of collected precedents, whether that law came from antiquity or it came from a statute. Cases get decided, they drop into the bin with their associated fact patterns, and from that we can kind of maybe make out, when we're just people walking around, what kind of things we can expect to do and not get in trouble in some way. All right, well, science, first of all, when we talk about scientific knowledge, we're talking about knowledge that's empirical. That is, it has something to do with looking at the real world and drawing inferences from the real world. Evidence is an empirical thing in a court. All right, and one of the nice things about the empiricism in this case is, as long as we can agree on how to count, right, that water bottle is the same as that water bottle, all right? And there's another water bottle and another water bottle, okay? And so the notion of identity and units, and can we count those? And that's something that we probably wouldn't fight over. Yeah, 1, 2, 3, 4. Some people might want to include the cup, the coffee cup, because they're all vessels that can hold water. Depending on what kind of questions we're going to answer, or we want to answer, we might want to include the cups. But in general, we can count, and so we can do empirical work. Next, science is a social way of knowing things. Just like I said, we can count. We can all agree 1, 2, 3, 4, or 1 unit, an additional unit, an additional unit. With scientific knowledge, it's we who are doing it. And we do it according to some kind of established set of rules. And this may go beyond just counting, right? It could go to a general line of reasoning. Right? And reasoning is a kind of a social thing, kind of a process that we can all agree on. I think that comes booming out in Come Ho Tire, where we didn't have an expert who was qualified as a scientist, but the expert had experience and skill, and the question was, did he have a process of reasoning and that he relied on that would reliably allow him or her to detect or predict tire failures or tire failure rates or whatnot. Then another attribute of science is it's practical. We're not in a search for cosmic truth. Yeah, I guess, maybe some Darwinists or evolutionists are, they're trying to explain the origins of the universe and whatnot. Okay, good luck. But generally speaking, we're not looking for cosmic truth. We're looking for practical solutions to real-world problems. How do I lift that heavy thing over there without breaking my back? We can get me and you and a couple other people, we can get under there and strain, all right? But maybe we get a little smarter than that, and we come up with a concept of leverage, and eventually we figure out how to make a hand truck, and we use the hand truck as a lever. And I have a hand truck at my house. I'll never go any place without my hand truck. I mean, I'll go to the store, but if I'm moving from one state to the other, which I just did, I take my hand truck. You wouldn't believe how many things you can lift with a hand truck. And then finally, science is agnostic. Science doesn't take a position that we've discovered truth. All science says is, for the time being, we have a theory, we've tried to test it, we've failed to reject it. And maybe we can use it, practically speaking, and it works. But otherwise, the process of science is agnostic. Now, one of the questions you might want to ask is, well, are there other ways of knowing? I think there are. I mean, some people are devoutly religious, and presumably that allows them to know something, and they think they know something. And in that realm, if they think they believe it, they know it, then that's good enough for me. I've done a lot of hunting in my time, and one thing I've learned, I'm not an expert by any means, but when you're trying to find a wounded animal, which is ethically the thing you should spend a lot of time doing if you're a hunter, you don't just, oh, got away, it'll die someplace. No, you really go after it. You actively seek that wounded animal, all right? And with tracking, you have to believe in yourself. Is that rock that's just slightly turned over, or is it slightly turned over? And you got to read signals and signs, and they're ephemeral, they're vague, but you got to believe in yourself. And I don't think that's science, okay? But it is a way of knowing. And anybody come up with any other candidates? Ashley, are you there? I don't know if I have any questions because the iPad screen is out here, is black. So, no questions? So will it go off by itself? I just hit that? All right, thanks. Interestingly, you know what I need to do if I'm going to do this again? I need to get a white lab coat. I keep telling myself, Johnsen, go get a white lab coat and have it embroidered with Dr. Johnsen. Yeah, people tend to think of scientists as people in white lab coats. This photo of these 5 people in white lab coats with test tubes in front of them, it was taken from a source. The source was bad stock photos of my job. In other words, when people who do real science want to yuck it up, they put on white lab coats, okay, and they take pictures of themselves with test tubes in front of them. That's how they prove to people that they're scientists. But science has nothing to do with white lab coats, not necessarily anything to do with experiment. We might go with experience. All right? As to the scientific method, what I'm going to do here is just follow, I think the court cited him in Daubert. Sir Raymond Popper was generally regarded as one of the 20th century's greatest philosophers of science. One of the main points he made that was startling to the world, and that I want to make because it still hasn't quite sunk in if you listen to people and how they talk casually, and I mean some very important, knowledgeable people who should know better. A theory in empirical sciences can never be proven, okay? But it can be falsified, meaning it can and should be scrutinized by empirical evidence. So the first time I had anything to do with the science course at the Law and Economics Center, I was the director of the Law and Economics Center. I'd just come from Wharton, and there was a program on the schedule already on science. And we had two speakers I'll mention. We had Leon Lederman, who at the time was the director of the Fermi nuclear lab, the Fermi accelerator, where they accelerate atomic particles and do experiments. So he was an empirical physicist. And then we had a wonderful gentleman, many of you have met him and listened to him with fascination, no doubt, Jim Trefil at George Mason University. Okay? Apparently Henry had hired Leon Lederman, and I don't think Leon quite talked about the kind of stuff that Henry thought was the judges should hear, but some of it they should hear. And so they're talking, and is it right? Leon said, well, you got one of the best guys in theoretical physics right on your faculty, Jim Trefil. Well, anyway, so we proceeded with the lecture. Leon Lederman got up there, and he talked about his work, and he said, well, we did this experiment, and we proved this. And we did this experiment, and we proved that. I'm pulling my hair out. One thing I wanted him to say was just, there is no such thing as scientific proof. So I had a little talk with Jim, and Jim very diplomatically, when it was his turn to speak and Leon was there, I kind of just, worked out of Leon that, well, did you really prove it? Oh, well, of course not. Everybody knows that. Okay, but that was the way he kind of talked. Because they've got such a rarefied environment with this, everything, all outside influences that they know of are kind of held constant and controlled. And so they can kind of, they think they can exclude a lot of possibilities. And then so the results of their experiment, they said, well, we proved that. We proved that. Okay, and it's just loose talk. And Leon Lederman, of course, knows better. And we got that one straightened out. Well, if you listen to Jim Trefil, I've shamelessly borrowed one of his diagrams or recreated it. In science, we basically start looking out at the world. Okay, we observe things. This big bright thing moves across the sky every day. At least every day it's not too cloudy. Night turns to day. Day turns to night. There's this thing we now call the Big Dipper. It's up in the sky. It seems to be there. It seems to move across the sky at night. There are just regularities. I had a big set to with my sister-in-law. We drop an object and it falls to earth. I was trying to tell her there is no scientific truth. And she said, there it is. That's truth. Okay? And she's, of course, had a motive. What do you think her motivation was? She is desperately battling moral relativism in her life. And she just, she didn't want it. There is truth. There is truth. Yeah, sure, there's truth. It's just not scientific. It doesn't come from science. All right, so we look out at the world and we observe the world. And then eventually, after observing enough, we see patterns or regularities. Things kind of repeat themselves, and there's a persistence to them. And then we might develop a general theory, kind of an abstract statement that is somehow going to capture the patterns we see, we hope. And in science, then, what we do is we use that theory to generate predictions. And then the question is, when we then go out and observe the world, are the predictions consistent with the facts we observe? And if they are, we say the theory has been what? What do we say? We might say it's been confirmed. That's loose talk. We fail to reject our theory. That's what we can say. So fail to reject. Let's talk about observation. I believe one of the implications of Plato's Republic, he talks about this, these prisoners, right? They're down here in the lower left. They're chained in position. They can't even move their heads. And behind them is a roadway, the roadway of life. People are coming and going back and forth. And behind them is a fire that provides light. And the fire casts shadows, or the fire illuminates the people on the roadway, and those people cast shadows. Well, these prisoners are there so long that, as far as they're concerned, the reality is just the shadows. Shadows of people walking by. They don't know that they're actually people. And so one of the problems with observations and observation, it's an inherent problem, is, what is it we're actually looking at? And is the thing we're looking at and observing, is it the true thing? Well, if we're talking about coming up with theories, then we might kind of think, well, there's actually something else that's casting this shadow, and all I'm seeing is the shadow. And I don't know if you'd have to ask Jim Treffel, but did this kind of pave the way for the ensuing skepticism over many, many, many hundreds of years toward any kind of empirical method of knowing or understanding the world? I don't know the answer to that, but it's clear that until maybe the 15th or 16th century, most knowledge was conveyed and developed through what are called scholastic debates. Learned scholars would gather together and they'd debate. Right? And maybe they'd use as their premise, well, Socrates said this, and so said a circle is the perfect form. And then so everything must be a circle. They thought the planets orbited the sun or the Earth in a circular path because circles are perfect. And this went on for centuries and centuries. And all of it was pure deduction. They knew math, right? They could do math, at least for rational numbers. They were very good. They developed algebra, geometry, and so on and so forth. They had a lot of knowledge. But the notion of actually going out and looking at the world to determine, whether to accept some theory or reject some theory was just foreign to them. So there's the famous story, it's in your reading, or alluded to in your reading, about the scholastic debate at Oxford, and the question was, how many teeth does a horse have? And they debated, went on and on. And then time for the graduate students to ask questions. The graduate student raises his hand and says, there's a horse right out in the courtyard. Why don't we go out and count his teeth? And the quote is, and they fell upon him and smote him hip and thigh and cast him from the house of learned scholars. Okay. They didn't want to hear about empirics. Okay. Well, that gradually started to change. I guess one representation of that is, I think in the 15th century, maybe it was one of the Medicis in Italy, got a hold of a cannon, okay, which was new at the time. And how many people have been to Italy? Right? It's just amazing at how many resources were devoted to defense, right? You see castles, you see cities with walls around them, just tremendous resources devoted to defense. Okay? I take those to be kind of realistic defensive projects in Italy. Now we get to England, you know that most of the castles in England were not built for defense. No, they have, at least if you believe the show on castles or whatever it's called, right? Why were they built? They were built as displays of wealth, right? And they were kind of caricatures of real castles. Right? They were never used for defensive purposes. If you want to get a real interesting insight into that in British and French aristocracy, there's a book called The Institutional Revolution, which is an economist's explanation for why we had all these weird things in the aristocracy. And it kind of ties everything together, makes a lot of sense out of it, not just conspicuous consumption. In any event, the ruler here who got this cannon, he was interested in, well, what angle should I tilt the cannon at so that the cannonball will go the furthest? And he probably had mathematicians on his staff, and they could have done the calculations, and then maybe they could have had scholastic debates and, gone back and forth, but he didn't have time for that. He said, go out, take the cannon, and point it in various elevations, and shoot the cannon. And see which angle makes the cannonball go the furthest. So in that case, we went from kind of deductive reasoning and pure theory to empiricism. And maybe that was the day science started. But science is empirical like that. Like I say, we come up with a theory. Well, they had plenty of theories pre-science. In fact, that's all they had. And then with the dawn of science, that was essentially the rise of taking the actual facts in the real world as a way of informing our accumulation of knowledge. So pre-scientific knowledge was deductive, not empirical. Mathematics kind of dominated the landscape. I don't know, question that comes to my mind, did scientific empiricism usher in the Renaissance? There are people a lot smarter than I who know about that. We got the printing press, which basically lowered the cost of reading material. There was a payoff then to the common man to becoming literate, and a lot of knowledge became diffused. Does anybody know, Latin fell out, the language Latin fell out of favor or fell out of use back in 600 AD. But then at some point they resurrected it, especially for communicating scientific knowledge. Does anybody know when that happened? Why? Why use Latin? Yeah, all other languages that we know of have some foundation in Latin for sure, right? But it was the language of the Roman Catholic Church. Okay, so it's not subject to this constant turmoil, right? We can kind of fix it in time and in substance. Well, I have a theory, and that basically communicating knowledge, scientific knowledge, for example, in Latin was their form of intellectual property protection. Right? So they didn't have patent laws or copyright laws, but what they did was, the learned class could discuss things in Latin, and therefore, and I think hope to keep that knowledge from diffusing more widely. It's just a theory, I don't know. And one of the tests of the theory that I was just asking about, that I don't know the facts, did this kind of reuse of Latin kind of emerge with the dawn of scientific empiricism. Something to ponder. All right, let's see. We'll talk about patterns. I already talked about that. We have motions of the planets. You know that we got the geocentric theory of planetary motion in the solar system. We got the heliocentric. Heliocentric obviously is one out. This heliocentric theory is simply a lot simpler. In other words, according to Jim, right, they can come up with mathematical models within a geocentric system that will, tell us the path of the planets. It's there. It's workable. It's just extremely complicated. Okay? And the heliocentric model is simply much simpler. And this brings us to Occam's razor. One of the kind of norms or pieces of advice in science is if you have two theories, one that's extremely complicated and one that's simple, always go with the one that's simple. Simple is good. Keep it stupid simple. You might ask, where do theories come from? And that's been a big debate. I mean, Karl Popper was involved in that debate. Does it come from, we infer something from the patterns, we infer generalization? Does it come from some deductive process? Does it come from imagination? So on and so forth. Those were important questions. Okay. So what are the kind of requirements of a scientific theory? First of all, to be a scientific theory, to be scientific, a theory has to have some observation capable of disproving it or refuting it. So it's got to generate predictions. The predictions have to be in the form of something we can observe in the real world. And those predictions have to be capable of not happening. Okay. So can anybody come up with an example? How many people have ever heard someone assert that the Trilateral Commission controls the world? Usually it's late at night in some smoky bar and there's some person down at the end of the bar mumbling to themselves. Yeah. And you make the mistake of going down, what's he mumbling about, And pretty soon you'll understand that he's a conspiracy theorist, and in this case maybe his conspiracy theory is that the Trilateral Commission controls the world. And the Trilateral Commission is composed of, Bill Gates, Steve Jobs, or when Steve Jobs was alive, Amazon, whatever. And they've got their representatives on the department, in the Department of Justice, and so on and so forth. So you say, or I have actually said this. Well, if you're right, the DOJ and Microsoft are both involved in controlling the world and setting output and whatever, all of the things. And then why is it that the Department of Justice brought a very costly lawsuit against Microsoft? What's the answer? Wouldn't that be, contrary to your interests if you're the Trilateral Commission? Why would you spend all this money to do that? Okay? It's to throw you off the scent, right? To fool you into thinking that there is no Trilateral Commission. Well, so then the question is, what fact could you observe that would refute the theory? How could you refute that hypothesis? We got others, God created it. Jim Treffel addresses this. There's this notion that scientists can carbon date and they can take a tree, petrified tree from, 10 million years ago, and it has tree rings, suggesting, like our current trees that have tree rings, that its life was such and such, and that it lived and died, so many millions of years ago. And then the question is, and the scientists might say, well, why would that be if God created the world 6,000 years ago? Well, it's the same answer, right? Because he did. And he created that petrified tree with tree rings. To fool you? I don't know. He just did it. Okay? Now, I'm not suggesting God didn't create the world. I'm just saying science, it's not a scientific hypothesis. There's also this maddening theory or body of knowledge out there called materialism. Anybody know what that is? Everything that happens, everything that exists in the world emanates from the real world. And the implication of this is what? People lack free will. Right? When I talk to one of these guys, I'm always tempted to go and punch him in the nose and say, well, the physical world dictated that I do that. And of course, his response is going to be, well, the physical world dictates that I have you arrested and sue you. Okay? But so the whole notion is we lack free will. But what fact could you use to refute the theory, the materialism theory? It's just, there is no fact. So it's not scientific. Now let's get down to the core of the scientific method. Scientific method relies, remember that prediction theory, prediction observation part of our cycle that repeats itself over and over and over, observation, patterns, theory, prediction, observation. Right in that prediction area, the question is what's being predicted and what are the kind of parameters on the prediction? Okay? The core of the scientific method is a simple logical syllogism. If A is true, okay, then B, an event, should occur. And if we take that as given, what can we say? Well, the one thing we can say is that if B fails to occur, that's what that asterisk or star is, that B fails to occur as predicted. One thing we can with confidence say is our theory has been refuted. And that's all we can say. So think of this. Suppose I tell you, if it's sunny on Friday, I'm going to go fishing. You go home, you check the weather, and you see, my gosh, it's raining in Destin. And you call me up and say, Bruce, I'm so sorry you didn't get to go fishing. Can you do that? Are you sure you're going to get the answer, yeah, I didn't go fishing? Any thoughts? No, you can't say that. I might have gone fishing in the rain. Okay. So just because A is somehow unrealistic or unrepresentative of the truth, okay, that doesn't disqualify it as a hypothesis. All theories are dramatic oversimplifications of the world, right? That's Occam's razor. Go for the simple, as long as it has testable implications that have not been rejected, over the complicated. So, I mean, this actually, this kind of thing was actually occurred. So let's take a famous example. Einstein's theory, general theory of relativity. One of the things he predicted was, in contrast to Newtonian physics, Newton hypothesized that light travels in a straight line. Okay? Einstein said, no, light and mass are related. There are objects, I hypothesize, that are large enough to bend light. And in 1919, they did that experiment, or they didn't do an experiment. They thought Arthur Eddington they decided that what they need is a total solar eclipse. Right? The notion was that if large objects with large mass bend light, then what should we observe in the heavens? For example, well, we should observe that during a total solar eclipse, that the position of the stars behind the sun, whose light is coming to us, should be deflected somewhat during the solar eclipse. And why solar eclipse? So otherwise you can't see the stars, so how do you know, right? So you got the nighttime sky and you got the stars in various positions, and they know what stars are what, and they've been there. And you take a photograph of that, and then you wait for a solar eclipse, and the moon blocks out the sun, and once again, you can see those stars. So the question was, had those stars at least apparently shifted their position relative to one another? And it appeared as though they had. They repeated it in 1922, so they did it a couple times. And this was startling to the world. Okay? So did they prove the theory that mass bends light? Can you prove a theory? No. What they did was they failed to reject it. There could be all sorts of other reasons that we've not even thought of why the position of those planets would either be different or appear to be different. Just never come to our attention, perhaps. Maybe there's some grand theory, and undoubtedly there will be, that will just as Einsteinian theory replaced Newtonian theory, something will kind of replace or at least largely dramatically modify Einstein's theory of general relativity. Okay? Constantly, science is just kind of progressing, moving forward, churning things, and so on and so forth. I think what we can infer from the experiment is often billed. Go on the internet and look it up. Oh, this experience or this test, it proved Einstein's general theory. I guarantee you, that's what you'll find if you go to Wikipedia. It didn't. What it did was it disproved Newton's theory that light invariably travels in a straight line. So Einstein's theory was not proven true. There's no such thing as scientific proof. There it is. Can you read it? The one bin is theories, full of papers. The other bin is proofs, 0. Okay. All right. Yeah. Okay. All right. So again, what the point here is that there are all sorts of theories out there. We have the theory that mass bends light. We could have some other theory to explain, position of stars. Still other theory. We don't even have a clue how many other possible theories there are. Why did I get up and go fishing in the rain? I don't know. Could be many, many, many reasons. My initial statement was, if it's sunny out, which means it's going to be a pleasant day, I can work on my suntan, which is obviously very important to me. But there might be some maybe the fish were just biting. I got a fishing report, and we're slaying the bonefish, 10-pound bonefish, every cast. I'm willing to go out in the rain. Huh? Maybe some other possible engagement I had fell through. And so the cost-benefit trade-off was, okay, might as well go fishing even in the rain. And yeah, so some of these we may not even know what they are. And so all of them might lead to the same prediction. So that's what I mean when I say science is agnostic. It just kind of tentatively accepts. The question is, what do we mean when we've confirmed a theory or we've validated a theory? That's not proof. And people use those terms, and it's okay to use them, but just make sure you understand what they're saying. Probably if they're saying validated, they might say they did an experiment a second time and they got the same results. Maybe a third time, and they got the same results. So they confirmed the results. Did they confirm or validate the theory? Not in the sense of proving anything. Okay? Now, so here's the question. If we start with if A is true, then B will occur, can we say then, I already addressed this, if A is not true, can we say that it's not going to predict? So let's take economics. What's the fundamental proposition in economics? Supply and demand. Actually, supply. Okay. Actually, the fundamental theory, kind of premise in economics would be that people are rational, right? And if people are rational, we can derive the notion that demand curves slope down and supply curves slope up. Right? Are people rational? How many people think human beings are rational? It doesn't even pay to be rational all the time, right? You get wedded to something and you haven't something invested in it. You stick with it. Right? You don't simply revise your understanding of the world and throw what you know out just because some fact gets in your way. Don't let the facts get in the way of a good theory. Ultimately, you have to, right? So the realism of the assumptions are irrelevant. What actually matters is whether or not the theory predicts. In fact, all scientific theories are false. Some are useful, and that's what we want. So we're looking for practical solutions to real-world problems. There's a map. That's a photograph of Washington, D.C. Is it realistic? It's a photograph from, 10,000 feet. Be inclined to say that's realistic, right? That's real. Okay, so if you want to get from the law school to Woodley Park Zoo, how do you get there? I'll give you this map and you go ahead and you find your way from the law school to Woodley Park Zoo. All right? Ain't going to work, right? This will work. That's a map, right? It's a map of the subway system, a metro system. It's totally unrealistic. Is it useful? You bet it's useful. I mean, the artists who designed this kind of scheme of laying out subway systems or maps for subway systems, became famous and did it. I think it started in Paris. But according to this map, the orange line, if we were talking about scale, the orange line would be a mile wide. Orange line's not a mile wide. But this map tells you what you need to know to achieve a very practical purpose. What about economics? I got about two minutes. What are the criticisms of economics? Social sciences are often called the soft sciences. Why is that? One thing about economics, generally speaking, is nobody's going to try and predict the magnitude. There are economists out there who say, okay, well, if we increase the minimum wage to $15 an hour, we're going to have an increase in unemployment of 1.4 million people, right? That's a pretty heroic statement. It's an estimate. Generally speaking, how much reliability does that have? If somebody says they're going to raise the price of butter 20% over here at the Whole Foods, how much less butter will be consumed? I have no idea. As economists, what we'll say is, if they raise the price of butter, holding everything else constant, people are going to consume less butter. So we're not looking to, as economists, we have a great deal of difficulty, because of a measurement problem, we have a great deal of difficulty kind of saying, you know, like a physicist could say, if we put so much water in a closed space and we heat it up, you know, the pressure's going to go up. They'll tell you how much the pressure's going to go up. But an economist can't say that. We can't, you know, predict those magnitudes. All we can say is that the pressure will go up. Okay? And that can be very useful. And especially when you're trying to involve yourself in the difficult task of explaining how people behave, people who don't pay their taxes. All right? So economics, as I said, is the only science that can predict the disappearance of a $10 bill. Okay? I think I'll stop there. Thank you for your attention.